Augmented Analytics. Lecture 1. Today we will learn about Introduction to Augmented Analytics. What is Augmented Analytics? How Augmented Analytics differs from traditional analytics. The role of machine learning in Augmented Analytics. Introduction to Augmented Analytics. Augmented Analytics is an approach to analytics that uses artificial intelligence and machine learning algorithms to enhance and automate data preparation, analysis, and insights generation processes. It is designed to assist business users, data scientists, and analysts to make better decisions by identifying patterns, relationships, and anomalies in data that may not be immediately obvious. Augmented Analytics leverages natural language processing, data visualization, and predictive modeling techniques to enable users to ask questions in plain language and receive actionable insights in real time. This approach to analytics can reduce the time and effort required for data analysis, increase the accuracy and relevance of insights, and enable organizations to gain competitive edge by making data-driven decisions. What is Augmented Analytics? Augmented Analytics is an emerging approach to data analysis that leverages machine learning and artificial intelligence technologies to automate and enhance the process of generating insights from data. It enables users to discover hidden patterns and insights in data without requiring advanced technical skills or expertise in statistical analysis. Augmented Analytics is built around the idea of empowering users to ask natural language questions about their data and receive automated answers in the form of visualizations, reports, and recommendations. The technology is designed to make the data analysis process more intuitive, efficient, and accurate by automating routine tasks such as data cleaning, modeling, and visualization. The goal of Augmented Analytics is to enable organizations to leverage their data assets more effectively by providing users with tools that enable them to gain insights faster and make better decisions. By automating many of the tedious and time-consuming aspects of data analysis, Augmented Analytics frees up analysts and data scientists to focus on more strategic and value-added activities. How Augmented Analytics differs from traditional analytics. Augmented Analytics differs from traditional analytics in several ways. 1. Ease of use. Traditional analytics typically requires users to have advanced technical skills and expertise in statistical analysis, programming, and data visualization. Augmented Analytics, on the other hand, is designed to be more accessible to non-technical users by providing natural language interfaces, drag and drop functionality, and automated data modeling. 2. Automation. Augmented Analytics leverages AI and ML technologies to automate many aspects of the data analysis process, such as data preparation, cleansing, modeling, and visualization. This reduces the time and effort required for data analysis and can enable users to gain insights faster. 3. Insight generation. Traditional analytics typically requires users to have a hypothesis or question in mind before conducting an analysis. Augmented Analytics, on the other hand, uses AI and ML to automatically identify patterns and anomalies in data and generate insights that users may not have considered. 4. Collaboration. Augmented Analytics platforms often include collaboration features that allow multiple users to work on a single analysis, share insights, and collaborate in real time. Traditional analytics typically requires users to work in silos, which can hinder collaboration and knowledge sharing. The role of machine learning in Augmented Analytics. Machine learning (ML) plays a critical role in Augmented Analytics. ML algorithms are used to automate many of the tasks involved in data analysis, such as data preparation, feature engineering, and modeling. In Augmented Analytics, ML algorithms are used to identify patterns, trends, and anomalies in data and generate insights that can help users make better decisions. For example, ML algorithms can be used to identify correlations between variables, predict future outcomes, and classify data into different categories. ML algorithms can also be used to automate data preparation tasks, such as data cleansing and transformation. This can save analysts and data scientists a significant amount of time and effort, and reduce the risk of errors and inconsistencies in the data. In addition to these tasks, ML algorithms can be used to enhance the user interface of augmented analytics tools. For example, NLP algorithms can be used to enable users to ask questions about their data in natural language and receive automated insights in response. Thanks for watching. Wait for more informative videos.